Okay, here's a big question for you. How do you move an entire financial system's worth of data? I'm talking millions of sensitive transactions, without losing a single cent or messing up a single record. It is one of the most high-stakes challenges in all of data engineering, because, trust is everything. So let's break down the framework that actually makes this possible.
So the job here is, well, it's just massive. We're talking about migrating absolutely critical credit card transaction data, and it's moving from this rigid kind of old-school Oracle system over to a super modern and flexible Databricks Lakehouse. And you gotta realize, this is not a simple copy-paste job. Oh no, this is a fundamental architectural leap.
And the scale is just wow. To put this in perspective, we have to safely move over 1 million transactions. And that's not per month, that's every single day, each with its own sensitive details like customer IDs, amounts, you name it.
Now, moving 1 million rows a day, that isn't just an impressive technical feat. It is a massive, massive risk. Let's dig into why.
Think of it like this. There's a giant chasm between the old system and the new one. The legacy world is rigid, with really strict schemas. The modern lakehouse? It's all about flexibility and speed. And that difference, that gap, it creates huge risks, like data just getting dropped into the void. Or even worse, something called silent data corruption. That's where a number looks right, but it's actually wrong. Imagine a single transaction's approval status flipping in transit. For the customer, that is an absolute nightmare. And for the bank, it's a catastrophic loss of trust.
So this is the most crucial point. The primary objective is completely non-negotiable. 0. Data loss. Every single transaction ID, every approval status, every single dollar amount has to make it across perfectly intact, period. So how on earth do you bridge that chasm and guarantee 0 data loss? Well, you build a firewall, but not for your network. You build one for your data quality.
And this really illustrates the solution perfectly. This framework acts as a 5-pillar quality firewall. So as the raw data flows in from the source, it has to pass through 5 distinct validation gates before it's even allowed into what we call the trusted silver layer, which is where it can finally be used for analysis.
And these are the 5 pillars that form the foundation of our firewall: completeness, accuracy, consistency, timeliness, and finally, anomaly detection. Each one of these is designed to answer a different but equally critical question about the data's health.
Let's start with the first two, which are, the absolute bedrock of data trust: completeness and accuracy.
Completeness answers the most basic, fundamental question of all. Is all our data actually here? Did every single one of those million-plus transactions make it from the source all the way to the target? And here's exactly how we check. On the left, you see the logic. It's a pretty simple SQL query that calculates what are called control totals, just things like the total row count and the sum of all transaction amounts from both the source and the target. And on the right, that's the artifact, a daily reconciliation report. It gives a clear, simple pass or fail. If that variance isn't 0, we know right away that something went wrong.
Okay, so we've confirmed all the data is present. It all arrived. But the next crucial question is it correct? Is it valid? And that's where the accuracy pillar comes in.
Now this is really cool. This is how we enforce the actual business rules. The logic on the left is basically a query that's hunting for violations, like an approval status that isn't one of the allowed values, like approved or declined, or a transaction amount that's somehow negative, which shouldn't even be possible. Any record that fails these checks is immediately logged in a data validation report, just like you see on the right. This catches errors before they can get in and poison our analytics.
All right, let's move on to the next pillars and see how this all builds. We've confirmed the data is present, and we've confirmed it's correct. Now we need to make sure it's consistent, on time, and free of any strange patterns.
So consistency is all about referential integrity, which is a fancy way of saying we're making sure the data makes sense in context. This orphan detection logic checks for transactions where the customer ID doesn't actually link up to a real customer in our main list. Those records are then flagged as orphans and just set aside to be fixed. Next up is timeliness. And this is huge because financial data is basically useless if it's old. So this freshness monitor calculates the lag between the actual transaction date and when it lands in our system. That dashboard on the right gives us an immediate visual. Are we compliant with our service level agreement, or is our data arriving too late?
And the final pillar is the most sophisticated one, anomaly detection. This isn't about fixed rules. No, this is about statistics. The logic here uses something called a z-score to find transaction amounts that are statistical outliers. Say a $5,000 charge in a fast food merchant category. That seems a little weird, right? It's a really powerful way to flag potential fraud that simple checks would totally miss. So when you put all 5 of these pillars together, you get a really powerful transformation. You move from a state of risk to a state of absolute confidence. Instead of some opaque migration process with manual spot checks and just hoping for the best, you get automated 5-point validation. And instead of that constant risk of silent failures, you get proactive, exception-based monitoring.
It effectively builds a solid, trustworthy bridge over that data chasm we talked about earlier. This framework ensures the new Databricks Lakehouse isn't just some storage repository, it's a trusted financial ledger you can actually count on.
And this is the payoff. A control tower dashboard that gives every single stakeholder, from the engineers to the executives, a single, clear view of data health. You can see rows ingested, the data quality success rate, latency, and an overall quality score. This is what builds true confidence in your data.
So this leaves us with a final question to consider for any data system you work with. Is your data just being stored somewhere? Or, thanks to a robust quality framework like this, is it truly being trusted?